All right, so this is the notes for Friday. This is section 4, and this is imaginary numbers. Some of you talked to me about what you're going to be missing, and I explained to you, we are going to talk about how to work, add, subtract, multiply, and divide with imaginary numbers before we actually kind of talk about what they are. You can do it the other order, and that's fine. I think both methods are fine. I just feel like with you guys, just because you lost some time during quarantine in Algebra 1, it might be better just to kind of make sure that we remember how to add, subtract, multiply, and divide before we try to teach you exactly what an imaginary number is. So this should not be a review like from quarantine. This should be like you did this in geometry, and you guys did this in Algebra 1. So I would like you to simplify the following. So I want you to leave them in radical form. So take a minute on a scratch sheet of paper, and I would like you to simplify these. Pause if you need to. Simplify them in radical form. So I'm just going to write 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, is 64. I was jumping the gun. 9 squared, 10 squared, and I could keep going, but I think that's going to be, well, let's do it. 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, 16 squared, 16 squared. Sorry, I was jumping to 18 squared. 16 squared, 17 squared, 18 squared, 19 squared, 20 squared. Lost my mind. All right, so we're just going to kind of talk about these a little bit just so you can kind of see what is going on here. So the birthday cake method, I know a lot of you learned from Mrs. Carlson or Mrs. Barkell last year. And it's a good method, except now that we're getting into Algebra 2, you kind of want to do the birthday cake in your head. If you're doing the birthday cake on these problems, on some of these simple ones, you're going to be in trouble. So I would just think about what of the purple goes into 20. Doesn't 4, that's my purple, and it's 4 times 5. Well, 4 is a perfect square, so that can come out of my radical, and that would be 2 root 5. Okay? So same thing on 300. If I think about 300, 100 is in my list. And so then I would do 100 times 3. Well, 100 can come out of my radical. The square root of 100 is 10. So this is 10 root 3. Same thing on the next one. If I think about my list over to the side, I would have 25 times 3. And then 25 can come out, so that's 5 root 3. And if I look at the next one, 10, nothing over on that list goes into 10, so then that is simplified. Okay? So we're going to think of this. This is in your notes, QF4. If I do the square root of 50, I know that's the square root of 25 times 2, which is 5 root 2. Now, if you do the square root of a negative number, you can't square root a negative number. It doesn't work because to square root, it has to be the same. The issue with that in the class that you're learning right now is that we still want to be able to do math with that, and I need to teach you how to do the math with that, but before I can, you have to know the operations. So I'm going to just teach you kind of a little trick. I wasn't the day they decided this, but they decided that if you make the square root of a negative 1 equal to I, okay, then you could actually say this is the square root of a negative 1 times 28. I'm going to do a lot of steps here. You don't need this many. I won't on the next one. But we know the square root of a negative 1 is I. And now I can think what goes into 28 that's on my purple list. I should just bring this puppy down. Keep it with me always. Okay. So what's on there that works? A 4. So this actually ends up being I root 4 times 7. So this ends up being 2I root 7. Okay, now you could write it root 7 times 2I, or, I mean, the order of it doesn't matter because it's multiplication. but I would strongly suggest keeping the root 7 last. What some kids do is they put it first and then they partially put the 2 underneath there, and I have to take off for that because the 2 is not underneath the radical. It was a 4 and you took it out of the radical. So if I were you, I would write the radical last just so that there's no confusion. Okay, so again, we're going to do this a little faster. If there is a negative, I'm going to actually just pull out an I. That's telling me that the number inside of the radical was negative, but I'm doing math with it. So it's kind of just like a light, like a beacon telling a person like it was negative, but I still want to do the math. So this would be 100 times 2. The square root of 100 is 10, so this is 10I root 2. Some kids will write I 10 root 2. It doesn't really matter, but if I were you, I would write the number in front of the I. Okay, last one. So if it's a negative, you're going to put an I to hold and to tell people it was negative. And if I look at my list, 4 goes in there. Don't write this down. 4 times 8, so then this would be 2I root 8. But if I look at my list, 4 still goes into 8. So 4 times 2, so I take that out, it's 2, so 2 times 2 is 4. This is 4I root 2. Okay, now I'm going to use a bigger number. Instead of using 4, I know 16 goes into 32. And the square root of 16 is 4. So I'm trying to make a point here. Any number on the list can help you simplify, but if you choose the smaller number, then you may think that you're done when you're not. You should get 4I root 2. You can't have multiple answers on this. Everybody will get the same answer. But if you use the bigger number, you're only going to have to do one step. So you want to kind of find the biggest perfect square that goes into the number. Okay, so we are going to kind of talk about some of this stuff more on Monday when you get back. But just this right here is my square root of a negative 1. So this is my I variable, and it's allowing me to continue to do math. So it is the imaginary part of a complex number. We're going to talk about a complex number. Okay, a pure imaginary number is when it's only imaginary. Those are the ones, like if I had 3I, that must have been the square root of 9. The square root of 9 is 3, and since it's a negative, you're going to have 3I. This is called a pure imaginary number. We're not going to really get too much into that, but we are going to talk about that as we move along. A complex number, okay, is something like 3 plus 2I. It's going to have a real part, and it's going to have an imaginary part. And again, I wish they didn't call it imaginary. If I was at the math meeting, I would have been like, please don't use the word imaginary, because then kids think that it doesn't exist. We're going to show you, we're going to talk about ways where it does exist. We're going to get into all of that. But right now, all your assignment is tonight is to add, subtract, multiply, and divide. You're just working with them. Okay, complex conjugates are going to be important to us. So if I have 3 plus 2I, the complex conjugate is going to be 3 minus 2I. So it's keeping the real piece stays the same, plus the imaginary. And so this is going to end up being 3 minus, the real part minus the imaginary. If you notice, I did not change, and I'm sorry for my writing. I explained on the video from yesterday, for me to get this iPad to work and record, I have to have it in the upright position. So I'm trying to write when it's like standing vertically. It's difficult, so it's worse than normal. Anyway, with that being said, the real part did not change. It's just the imaginary part. And we're going to look at some examples of this, but just remember, it's just the imaginary part that changed. Okay, so if I simplify these, just going back to Algebra 1 review, okay, if I simplify these, 8 times 12, I don't have a calculator here. My brain is fried because it's the end of the day. So 48, what is that, 96? Okay, and I know that 16 goes into 96 6 times, so this ends up being 4 root 6. was trying to put that thing there. Well, I guess that's gonna for right now. Now, could you have, I just want to show you something. Could you have done this where you simplify the 8? So this would be 4 times 2, which is 2 root 2. And then simplify the 12, which is 4 times 3, which is 2 root 3. And so now I times the outside and the inside times the inside. So I get 4 root 6. So I could multiply and then simplify, or simplify and then multiply. Okay, both of those would work. So if I look at the next one, since I did this first, I could do the square root of 5 times, this would be 4 times 2. So the square root of 4 is 2. So your answer would be 2 root 10. Okay. On the next one, I would say 3 times, this is the square root of 4 times 2. So this would be 3 times 2 root 2. So my answer would be 6 root 2. And multiplying these, I would have the square root of 4 is 4, the square root of 4 is 4, 2 times 2 is 4. You could have also multiplied them together and then simplified. You still get 4, okay? Adding, you cannot add these. You can multiply any of them, but you can only add if they are like terms. Now, they aren't simplified because 8 could still be written as, we've done this one a few times, isn't it, 2 root 2? But they're not like terms, so this would be my answer. Okay? All right. So we're going to simplify. Okay? So we have a negative 3 times 2, that's negative 6. And then we have I times I, and that's I squared. So I need to show you something off to the side. This might be the most important thing I'm talking about today, and we're going to get way into this, so it's your first day seeing it. Remember I said I is the same thing as the square root of a negative 1. Okay, so if I think about that, 3, right? And so if I did the square root of 3 times the square root of 3, wouldn't that be the square root of 9, which equals 3? So I'm back to the same thing that was inside of it, 3 times 3. Okay, so if I would have done 5, the square root of 5 times the square root of 5 is the square root of 25. So wouldn't I get back to what was inside of it? Okay, so the same thing works here. If I had I squared, wouldn't that be the square root of negative 1 times the square root of negative 1, which actually would just be a negative 1. A lot of people are out there saying, Miss Williams, you screwed up. It's a positive 1 because a negative times a negative is a positive. But you have to remember that this is like terms. So I'm saying a negative 1 to the 1/2 times a negative 1 to the 1/2. When you multiply, you add exponents. And in 1/2 plus, I don't know why I put a negative there because I'm crazy. 1/2 plus 1/2 is 1. And anything to the first is itself. I just made a mess. Okay, 1/2 times 1/2 is 1, and anything to the first is itself. So you have to understand that anywhere in your homework, if you get an I squared, you need to convert that and write that as a negative 1. So the answer to this is 6. Okay, and I'm not sure, I got to check here. Desmos may or may not do this. So I'm going to check. I wish my calculator does. You have an I button on the calculator. I'm trying to see if I can get, let's just maybe try what it says if I do 3i times negative 2i is, yeah, don't listen to that. I've lost my mind. Yeah, don't listen. Don't try it on Desmos. You can try it on your calculator, but do not try it on Desmos. That's messed up. Okay, so if I do the same process here, you have to take the i's out first. So you have I, and 12 can be 4 times 3. So this is 2i root 3 times I root 2. So wouldn't I have 2i squared root 6? I will never accept an I squared in your answer, so you would have to change that to a negative 1. So your answer is that's negative 2 root 6. Okay, so I would just attempt these. All right, solving. Let's take a look at this. I can't factor because it's not a minus, as 2 terms. But I can look at this and say, wait a minute. I can solve because I have a squared and I don't have a b. This is the only time you can solve like algebra. So I can minus the 20, divide by 5, and then you square root. Well, you can't square root a negative number, so you have to let people know it was negative. So you're going to do plus or minus. Remember, when you square root, you have 2 answers. You're going to do plus or minus I root 4. Well, what is the square root of 4? The square root of 4 is 2. So your answer would be plus or minus 2i. Okay? So when it doesn't have a b value, you can actually solve it. All right. So we're going to just kind of run through adding, subtracting, multiplying, dividing. So on adding, this is very easy. It goes back to Algebra 1. These are like terms because they are real. These are like terms because they are imaginary. 2i minus 2i is 0, so my answer is 8. Okay, so the same thing here. You're going to add together the real part, and I lied, it's not adding, it's subtracting. Negative 1 minus 3 is a negative 4, and then you're going to combine the imaginary part, so 2 minus a minus 4, that would be a plus 4. So that would end up being 2 plus 4 is 6i. So I would write it in complex form, which is a real part and then the imaginary part. So adding and subtracting is not that bad. Okay, multiplying. You do it just like you multiply in algebra. So negative 4 minus 10i minus 6i minus 15i squared. So that would go together. Okay, and then let's discuss this. You can't have I squareds. I squared is equal to a negative 1. So what is a negative 15 times a negative 1 is a positive 15. I lost my I. So these are like terms. So my answer is 11 minus 16i. Okay, you can never have an I squared in your final answer. You have to simplify it. Okay, before we do the next one, I do want to show you that the original question, this right here is exactly the same as this right here, except that this sign is positive and this sign is negative. Everything else on that, the negative 3, the 2i, they're all the same. So these are what we call conjugates. I just spelled that wrong. You can tell it's the end of the day. I can never. Conjugates. Okay, so these are conjugates. So I'm going to multiply this. So when I multiply, I would have 9 plus 6i minus 6i minus 4i squared. Well, if you look, your conjugates are going to always cancel in the middle. And then this negative 4i squared would actually turn into a plus 4 because this piece is a negative 1. And 9 plus 4 is 13. Okay, so the last thing, so multiplying is easy. It's just FOILing. You just have to remember I squared is a negative 1. We are going to talk about why. This goes back to some of you asked me this question and you said, what am I missing? And I'm like, it's going to be strange because we're going to just learn to add, subtract, multiply, and divide. Then I will show you what all this I stuff means. It's just I can't do all of it in one day. So we're going to just practice add, subtracting, multiplying, dividing. And then we'll talk about what the I actually stands for. So on the next one, this might help from geometry. And Ms. Carlson, Ms. Barkell both told you, like in geometry, you couldn't have answers like this. You couldn't have radicals. The rule is you can't have a radical in the denominator. Well, if you think about it, I is a radical. It's the square root of a negative 1. So you have to get rid of that. So what we're going to do to get rid of it is we're going to multiply by something that would turn it into a number. Well, if I multiplied it by itself, and you can actually do it by I, but I'm going to just do the whole entire thing. Then on the bottom, wouldn't I get 4i squared? And wouldn't I squared become a -1? So wouldn't this be a -4? Okay. Now on the top, I would end up with 4i. I don't know why I just did that. That was ridiculously dumb. Plus 6i squared. Again, I squared is a -1, so this whole thing would become a -6, so this would be a -6 plus 4i. I would not accept this as an answer because everything is divisible by 2. So this would be a -3 plus 2i over 2. Now, I'm going to tell you right now, I don't know. Someone in your class, instead of multiplying, I'm just going to show this with like a pink sign. Someone in your class might say, Miss Williams, multiply by a -2i. Okay, fine, right? That would make that a -4i squared and a -4i and a -6i squared. So this becomes a -1 times a -4, so that would become a plus, that would become a plus, and that would become a minus. So let me write the answer. Wouldn't you end up with a +3 minus 2i over 2? These are essentially the same answer, so you got to be careful when you're checking with a friend. If you have the same exact answer, but you have different signs, then you're both right. And we're going to talk more about which one is necessarily the better answer, but right now I just want you to practice getting rid of the denominator with a radical. Okay, so if we think about this, if I multiplied, we come back up here to multiplication. When I multiplied conjugates together, didn't it give me a whole number? Okay, that's the reason why it's important to know conjugates. And we're going to use conjugates all semester, just not always imaginary. Okay, so my conjugate would be 2 minus 3i. I'm doing the conjugate of the bottom because I want the bottom to become a whole number. So if you multiply the bottom by 2 minus 3i, you got to multiply the top. So now you're foiling. So on the top, you would get 6 minus 9i minus 4i plus 6i squared. Okay, plus 6i squared would become a -6. So 6 minus 6 is 0, so I'd have a -13i on the top. Then let's do the bottom. That would be 4 minus 6i plus 6i minus 9i squared. The middles cancel, and this would become a +9. So 4 plus 9 is 13. So basically 13 divided by 13, the answer to this would be a -i. Okay, these are harder. I'm guessing on Monday we're going to have to work some more on division. So let's try this one. It's just practice. Go ahead and pause it. So you're going to multiply by the conjugate, which would be 1 minus I. So on the top, you would get 3i minus 3i squared. And on the bottom, you get 1 minus I plus I minus I squared. My middles would cancel, and a minus I squared would become a +1. So on the bottom, I would have a 2. And on the top, this would become a +3 and then +3i. Just covered the answer. Okay, so again, my big thing is you have to think about multiplying by the conjugate so you can get the denominator to be a whole number or integer, just not anything with a radical. And then just try your hardest, multiply, add, subtract, and we'll probably work on divide some more on Monday, but I know there's going to be a quiz over just operations after I do homework questions. So you don't want to have done nothing. All right, have a good weekend. I hope things go awesome for all of you.